How to design a foundation for pre-engineered buildings. This is a pre-engineered building that we have. Foundation designer. Sorry, let's analyze the structure first. सही है, everything is okay. आपके load combinations good. ठीक है, structure is passed. Now we go to the foundation design. You just take the primary load cases. You will not take the combinations. ठीक है जी. You include them, then you run STAAD foundation. STAAD foundation में you can see that you have these two foundations isolated. ठीक है जी. इसमें आप ये अगर चीज़ें फिल करना चाहें तो कर लें, बट इफ़ वी कम डायरेक्टली टू द value, तो we have column pedestals. So yes and yes, we have column pedestals. The height of pedestals depends on the geotech report, but generally let's take 3 feet and 3 feet. और फिर since this is a pin connection, तो ये pedestal भी जो है that depends on the size of your column. So I have a column here which has a depth of 250, right? So let's say if I add 75, 150, so I'll probably have 450. This can be 1.5 feet, pedestal length 1.5, and this can be 1.5 into 1. So this can be a tentative pedestal size for design as a pedestal. Okay, now next what you do is you create your load cases. You have your generated load combinations. You have service loads against which the soil will be checked. Your structure has been designed according to the AISC 2005. So keep this 2005. Now you can generate the ULS load combinations, strength combinations, and the service load combinations for the soil check. Once that's done, you go to the soil property. Nothing to change here. You don't have any complicated. Create a new job. Let's call this ISO foundation, and this time we'll take only combinations. ठीक है? And create a job. You can have other options here if you want to see them. I don't see anything which is useful. The code is here, support and everything, and let's create a job. Now you have a foundation job created. Design parameters: concrete is 3000 psi, steel remains 60. Minimum bar of the size I want it to be in 4, and maximum also I want to be 4. So the steel I want generally in foundations is dia number 4 bar, so half an inch dia. Minimum for the top again 4 and 4. This is out of experience. I like this. इससे ज़्यादा मैं बढ़ाना नहीं. I don't want to increase anything above this. Pedestal I would go for minimum 6 and let's say maximum 8. So pedestal tie bar I will have 3, and that's it. Maximum spacing 6 inches is good enough. Okay, now this is done. Now I go to the cover of the soil. Unit weight is okay. Value, let's see, I have this in kip per foot square. The bearing capacity, 1 ton bearing capacity should be around 2.2 kip per foot square. This is fine. The depth of the soil above the footing, since we have the pedestal for 3 feet, I'm assuming 12 inches, so this can be 24 inches. Fixed top, yes, let's fix the top, and then all of these are good to go, and then we are good to go again. Sliding and overturning, these coefficients and these safety factors are in accordance to this ACI, so no need to change them. You simply go to design, yes, save, and there you have it. Very nice, smooth structure design of your foundations. There you go. So you have 4 number 6. This is the size detail output if you are interested to. Otherwise, what you want to do is just want to create this, export this drawing, or a schedule of drawings, or this is a better drawing. So detailed drawing आपने जो है वो export कर देनी है. For the foundation number 1, save drawing 1, and then save drawing 2, Again, general arrangement drawing, save this as GA, calculation sheet, size. But just look at this. This is a very nice 9 feet by 9 feet foundation, and 60 feet is the size. This foundation appears to be a bit heavier. Now, in pre-engineered buildings, the key to success or the secret is that you increase this depth. So you have soil on top to counter the overturning. Most probably this is going on that. So usually what I do is I would increase the soil on top, and which I can do that from here. Let's see if I'm in feet, and I'll put this, let's say, just to see, let's say 3.4 feet, let's say. And if I now analyze this again, I'm assuming the size will be reduced. See, there you go. Now it's a 7 feet by 7 feet. In pre-engineered buildings, it's always a good idea to increase the self weight on top or the soil weight on the top. Now this is 12 inches thick. I'll probably go for a thicker one. Again, this might result in a smaller sized foundation. See if we can try minimum spacing, concrete, bottom bar size, and then this and this. Footing geometry, I would say the thickness should be minimum thickness. Minimum thickness is here 12 inches. Let me keep this for 15. Okay, let's design again. Seven feet by 7 feet. So if you increase the thickness and if you have soil dead load on top, it prevents overturning. So especially in cases of pre-engineered buildings, this always results in an economical solution. But you see the pedestal is not been adjusted here. We can go back and do this foundation plan and pedestal. This can be now pedestal height 4.5 and 4.5. Let's design this now. So even the increasing the height of the pedestal is adding more self weight, right? Stabilizing the foundation, reducing the size. So I have 6.83. So you can design this as 7x7 key foundation. Simple as that. Now this is here, this is here. The rebar is very nice. Main steel number 8 and pedestal main steel is number 4, number 6 bar in the pedestal. This does not appear to be at least we need to enforce minimum steel here for the pedestal. So you have 1 feet by 1.5 feet, Abdullah. So what should be the minimum steel here? 12 into 15 inches multiplied by 0.01, which is 1%. So 1.8. Now 1.8 is rebar dia. If number 6 bars are to be taken, 1.8 is almost 4 number 6 bar. So 4 number 6 bar should do the job. 1.76. So this is okay. So this is okay steel. Just simply replace the drawings we created with the drawings we have now after a little optimization of the foundation. And you go to the detailed schedule. Okay, and we can have this, or we can have, I think we're going to use this foundation for both the foundations. You just have this drawing. You're going to mirror it, na? You know, दोनों आपस में तो नहीं होंगी, mirror हो जाएगा. So this is the foundation drawing, and then this is the general arrangement drawing, which you need to make some changes to. See, we're going to enforce same size, the heavier size, 7 feet by 7 feet on both. There you have it. That's the foundation design. Simple as that. Nothing more, nothing less.